Hey everyone. So I'm making this video here. I'm calling this one I think 2.5 because it's not really necessary, and it'll probably be like 5 minutes. But I thought it would be helpful to step through an example of a proof with these sentences. Because something I talked about in the last video, which was a very, and if you know, you can skip this because we'll do a proof eventually with sentences, and so you'll see what it looks like to do a proof with sentences. But for the time being, it might be helpful to begin with an extremely simple proof with sentences. So let's work. Let's work with basically this statement. So I'll write the statement up here, and we'll just go give a brief proof of it in order to demonstrate the inductive way that you prove statements about sentences. So every sentence phi has the same number of open parentheses and close parentheses. So this is something we definitely hope would be true. I mean, innately, right? The whole point of parentheses is that you always add an open and a close. But let's walk through and just prove that this statement is true. And of course, this proof will be done by induction, and it's induction on the definition of a sentence. So for the base case, we observe that for any sentence symbol p, then p is a sentence. Or rather, I should phrase this differently, because I'm saying that every sentence phi has the same number of open and closed parentheses. So the base case would actually be if phi is just a sentence symbol, right, for some sentence symbol, then phi has 0 open parentheses and 0 closed parentheses. So that's the base case, right? And this is, of course, using from the definition we gave earlier. This is bullet point I. Okay, so that's the base case, and now we'll move on to the induction. And technically speaking, this induction is done on the length of phi. So just practically the number of symbols within phi. And one thing that I won't give proof of, but note that from our definition, if we had that whole if phi is a sentence, then not phi is a sentence, but not phi is strictly longer in length than phi itself. So like I said, all of these proofs by induction will basically break down into two cases. So first, let's say that phi happens to be of the form not psi. Okay. So by the inductive hypothesis, phi has the same number of parentheses. And of course, or psi has the same number. Has this? I should not be lazy. I should write it. Has the same number of open and closed parentheses, and of course, phi only adds one of each. So clearly, if we add precisely one open parenthesis and precisely one closed parenthesis, phi also has the same. That's case one. And, this might be a good moment to pause and see if you can piece through case two on your own to make sure you're following what this inductive proof looks like. Okay. So, right, step two now is, let's say that actually phi is of the form psi and what's another Greek symbol? I guess psi and pi will be fine. So say phi is of the form psi and pi. Well then, again, by the inductive hypothesis, phi and pi have same number of open and closed parentheses. And of course, phi adds exactly one open parenthesis and one closed parenthesis. So, the number of open parentheses in phi will be, the number of, open parentheses in phi is 1 plus the number of open parentheses in psi plus the number of open parentheses in phi, and you get the idea, right? So we're adding exactly one of each to the number of open parentheses in phi and the number of open parentheses in pi. And the same is true for closed parentheses, so we'll conclude that phi has the same as well. And then finally, to end all of this, by point number 4 in our definition of a sentence, this exhausts all possible phi. Right. So the point is, and this is why I said it was so important that we have that definition of, we have the if only if. I can do this induction, and now I can conclude by induction that all possible phi have been considered. So we conclude, of course, oh, this is it. This is our first QED. So that's the box, and we conclude that psi always has same number of and done. All right. So, yeah, that was 7 minutes. So, like I said, I'm going to stop it here. This is just sort of a 2.5, a little example of how you would prove something, or how you would prove something about sentences using induction. So next time, we'll dive more into the semantic meaning of sentences that we've constructed in propositional logic. So I look forward to seeing you guys then.